Good morning. It is very cool that you've come to this cool hall to find out how cool Xamarin.Forms is. If only I could define the word cool, we'd be in great shape. You can look up the word in Wikipedia and find out how the concept of cool has transcended cultures and eras. It is a universal truth that it is never uncool to be cool, or to use the word cool. But it's still a difficult concept to define precisely. Yet we're pretty sure we know it when we see it. There are cool cars and cool jazz and cool cats. You put a pair of sunglasses on a cat, the cat looks really cool. A pair of sunglasses on a dog, not so much. There are cool people. And there are very cool mobile development conferences. But what else? Are there actually cool APIs? Yes, absolutely. I think every programmer can recognize cool programming features and cool APIs. I mean, in one sense, this is what we live for. Now, when I first started exploring Xamarin.Forms, however, I knew that the concept itself was very cool. Writing cross-platform user interface code in C# and XAML, very, very cool. Yet, because Xamarin.Forms mostly implements stuff that is common to 3 platforms, I guess I really didn't expect to see a lot of cool in the API itself. Because once something has been implemented on the iPhone, and on Android, and finally on Windows Phone, at that point, almost by definition, it's no longer cool. So I was surprised to discover some coolness in Xamarin.Forms itself that I would like to share with you. Maybe you'll think this stuff is cool, maybe not. The concept's very subjective. But while it's also very cool that Xamarin.Forms is open-ended and lets you make your own platform-specific renderers, none of what you'll see here uses that feature. It's all pure Xamarin.Forms APIs. Can layout be cool? Now, Xamarin.Forms is built around a collection of visual elements, such as button and slider and label, that actually map to underlying native controls, so that what you get is an iPhone button, or an Android button, or a Windows Phone button. However, Xamarin.Forms implements its own layout system, various classes that derive from a layout class. Each layout derivative arranges its children in a particular way. The 2 most common are probably stack layout and grid, which arrange their children in a stack or a 2-dimensional grid. Now, I'm not going to claim that stack layout and grid are intrinsically cool. But even stack layout has some coolness. It has an option called expands that allows extra space to be allocated among children of a stack layout. It's a little esoteric. It doesn't sound like much, but once you see a need for it and you start using it, it's great. And I've tended to use it a lot. Another layout class is absolute layout, which would normally not be a candidate for coolness at all. Absolute layout is the most primitive form of layout. It positions its children using XY coordinates, just like we did back in the dark ages, before layout and auto-sizing were invented. And yet, the Xamarin.Forms implementation of absolute layout supports proportional positioning and sizing options that allows you to specify the position and/or size of the children relative to the absolute layout object. For example, a width of 0.25 gives your child a width of 1/4 the width of the absolute layout. And you specify values of x and y between 0 and 1 to position objects within the absolute layout. Give a button a position of 0, and you're aligned at the upper left and/or right or top of the absolute layout. Nothing special there. But you might assume that an x-coordinate of 1 would position the left side of the child at the right edge of the absolute layout, and hence the child would be outside the absolute layout. But no. A value of 1 positions the child flush against the right or bottom side of the absolute layout. In other words, the proportional positioning takes the size of the object into account. You need to watch out sometimes for off-by-1 issues. Sometimes this is a little bit of a hassle, but at other times it's great, because you can use values of 1 to right justify a child, or coordinates of 0.5 to position the child in the center. Let me show you this coolness in actual use in a program from the preview edition of my book, Creating Mobile Apps with Xamarin.Forms. Let's bring up Xamarin Studio, which I'm punching the Mac screen again with my fingers. OK. File, recent solutions, proportional dot matrix clock. This program creates a total of 238 box views in an absolute layout to simulate a clock that uses a 5x7 dot matrix display for the digits. And I'm sure we can all agree that 5x7 dot matrix is so retro, it's automatically cool. And it adjusts to portrait or landscape. OK? Now, you may think that this program might be a candidate for a grid, but I think it has too many children for a grid. So absolute layout is ideal. However, normally in such a program, you'd have to process the size changed handler for the page to resize and position all these box views whenever the size of the page changed. However, with proportional sizing and positioning, all that is done in the constructor. And the size changed handler, which you can see right there, is just one line long to set the aspect ratio. Now, anytime you can move a lot of code into a constructor or into XAML, that's cool. Let me go back to the slides. Xamarin.Forms also implements its own animation system. And of course, animation is pretty much automatically cool. Now, it exists basically in 3 API layers. At the lowest level, down at the bottom, is a class called animation extensions. And these are extension methods, the most important of which is called animate, that exists in several different forms with different kinds of callbacks. Next highest up is the animation class, which has a facility to group animations, so they run simultaneously. But it's all very generalized. It doesn't actually target any properties. It just goes through the math and has a progress factor to apply in a callback function. So you have a very versatile system so far, and you can pretty much use this to animate anything in Xamarin.Forms. But in most cases, you'll be animating values of some properties, and particularly transforms. So at the very highest level are a bunch of extension methods for visual elements in a class named ViewExtensions that do just that. These mostly target transform properties, such as translation, scale, rotation. The methods have names such as translate to, scale to, rotate to. Now, for the following demos, I'm going to restrict myself just to these methods, because when I first started exploring animation, this is what made me say, whoa, way cool. They are extraordinarily easy to use. That's one thing that makes them cool. Plus, you can make your own, more cool. Now, I don't have any animation examples in the preview edition of the Xamarin.Forms book. But when I get that animation chapter written, it is going to be way cool. Let's look at some basics here. Let me bring up a little program called Animation Tryout. It's just a button. Can you see this text OK? All right. I don't want to mess with it. It's just a button in the middle of a page, and there's an empty Lambda function for the clicked handler. Now, in a normal program, that clicked handler probably does something important. Otherwise, why would you have a button in your app? But you might also want to provide a little feedback to the user, perhaps by spinning the button around in a circle. So to do that, button rotate to 360 degrees. And let's compile this. And you click it, and the button goes around in a circle. That's it. Now, you can learn a lot about these animations by experimenting with them. For example, if you try to click this again, you'll see that it won't rotate. It's already at 360 degrees, so it can't rotate any further. But there is an easy way to fix that. We can begin the animation by just saying button.rotation equals 0. And let's change this from the default 250 milliseconds to 1,000 milliseconds, or a second. Let me get rid of that. I'm stepping on my punchline here. OK. Oh, no. Yeah, I messed up there. OK. No? Oh, yeah, thank you. This is the fun of live coding here. OK. OK, and now we can click it multiple times. Now, can we flip around these two statements? Can we set it back, set the rotation back to 0 after we rotate it? Let's try that. And no, that doesn't work. Did I mention that these methods are asynchronous? I didn't mention that. I forgot to mention that. They return task objects, actually task of bool to indicate if the animation was terminated prematurely or allowed to continue running to the end. That means we should be allowed to use a wait with them. And obviously, anything that you can use a wait on has some degree of coolness involved. So let's make this Lambda function async, this YNC, and await. And now it spins around, and when it's done, then it gets set back to 0. Now, usually in an animation system, you have a way to do simple linear one-shot animations like this. And then there's some rather messier, more complex way to do keyframe animations, which lets you stack animations in sequence. Now, besides the fact that it's really cool that you can do simple animations with just a tiny bit of code, what's really, really, really cool is that because of the await operator, you get keyframe animations essentially for free. For example, suppose that you did not want to spin that button completely around. You want it to swing one way, and then the other way, and then back to 0. That's a keyframe animation. But look at how easy this is to do in Xamarin.Forms. You do the first rotate to of 90 degrees, say over 250 milliseconds. 250. Do the next one. Minus 90 degrees over 500 milliseconds. And then the last one, back to 0 over 250. And let's get rid of that statement. OK, let's try this. OK, simple keyframe animation. Now, when I realized I could do something like this, I knew that this animation system was obviously invented by some kind of very cool genius. But I know what you're going to say, though. You're going to say, well, that is pretty cool, but what would be even cooler is if the movement weren't so linear. You know, usually when buttons go swinging back and forth in the real world, they speed up and slow down and all. Well, of course, Xamarin.Forms supports easing functions. And for something like this, easing functions based on sine curves are usually the best. So let's try setting the first one to a static property called easing.sineOut, which starts off normally but then slows down towards the end. And in the second one, easing dot sine in out, which means it's slower at the beginning and the end, but faster in the middle. And for the last one, a easing dot sine in, which is slower at the beginning. Oops, okay. And now the movement looks much more natural. What's also cool is that you can mix animation methods with a weight and animation methods without a weight to perform simultaneous animations. Now, if you do not await a method that returns a task object in an async method, you'll get a warning from the compiler, warning message from the compiler. Like all warning messages, you can just ignore that. Or you can set a pragma to turn it off. For example, suppose you want to spin the button around when it's clicked, but also make it get bigger and then return to its normal size at the same time. So you want a rotation and scaling simultaneously. Here's how to do it. First, let's initialize the rotation. Oh, come on, fingers. Come on, fingers. To 0. And then rotation, and spell it correctly, please. OK. Rotate to, notice 360 degrees in 2 seconds. Notice no await on that. So it's going to return immediately while the animation proceeds in the background. And then await on a scale to 5 over 1 second, and await of scale down to 0 over down to 1 rather over the next second. Let's get rid of those, and let's try this. So the rotation returns immediately, and then the scales proceed. So it goes like that at the same time. That is cool. Yes, thank you. Now, this technique isn't a complete solution to running animations in parallel, because it really only works well if they're somewhat synchronized, and that's not always possible. Now, for a really comprehensive solution to simultaneous animations, you have to go deeper into the animation API, which is not right now, alas. You can make your own easing functions. One way to do that, the boring way to do that, is to derive a class from easing, maybe define some properties and do it that way. However, we live in an age of Lambda functions. Lambda functions are cool. And certainly, a truly cool animation API would let you define easing functions as lambdas right in your code. And because Xamarin.Forms has a really cool animation system, that is precisely the case. Now, over the years, one of my favorite animation demos is something I call a jiggle button, or a shiver button, which is a button that jiggles a little when you click it, as if it's somewhat overexcited that you've actually clicked the button. Now, to use your own easing functions, you pass, let's get out of here quickly, and let's get rid of all this code. And let's go await button.rotate to. I'm going to rotate it to 15 degrees over 1 second. Now, to put in your own easing function, you instantiate easing and pass to it a lambda transfer function. And the default would just be t to t. OK? T for time, specifically normalized time from 0 to 1 over the course of the entire animation. Now, normally, 0 should transfer to 0, 1 should transfer to 1. You don't have to do that. Let's try something a little more involved. Let's go math.sine, math.pi times t. Now this is 1/2 of a sine curve. So it starts at 0, goes to 1, comes back to 0. This will be the overall contour of the easing function. Let's multiply that by another sine curve, math.pi times 20 times t. Now this goes 10 cycles of a sine curve, while t goes from 0 to 1. So what happens is that we have a one sine curve going to 0 to 1 10 times over the course of the animation. The other sine curves multiplied by that goes from 0 to 1 and 0 to provide an overall contour. Now, it looks as if we're animating the rotation angle to 15 degrees, and we're kind of doing that. But this value of 15 degrees will be multiplied by the output of the transfer function, which is going to start at 0, go positive, go with a bunch of cycles. So the angle will have maximum swings of 15 and minus 15, but it will actually end up as 0. OK, let's see what this looks like. OK. Now, that's a jiggle button that it's very versatile because you can actually fine-tune the easing function right in your code with a minimum of code. Tiny code plus versatility equals major cool. You may have noticed that all the rotations and scalings have been relative to the center of the button. That center of rotation and scaling is governed by anchor X and anchor Y properties. These properties are relative to the view being transformed. The default values are 0.5, which means the center. If you know about anchor X and anchor Y in iOS they're also used in positioning. In Xamarin.Forms, they're solely for animation centers, which makes the inside Xamarin.Forms a little to compensate for that little problem. I was going to type all this code in for real and take you through stages here. But I think that I will just go to the bottom, and rather than typing this all in, I'm just going to copy and paste. That's the simple way to do live coding. OK, so what we have here is sets the anchor X to 0, anchor Y to 1, and that's the bottom left corner. And it rotates to 90 with an easing function that makes it swing back and forth as if it got dislodged, and and then it drops down to the bottom of the screen. And then I change the anchors to the upper right corner. At the same time, I adjust the translation so it doesn't move. And then I rotate it twice, and so it keels over dead, upside down with its feet in the air, so to speak. And then it fades out as it ascends into heaven. OK? All right, you ready? Because once this is a one-shot only. I'd have to rebuild the program to make it do it again. OK, ready? OK, and it drops down to the bottom. Boing, falls over, and then goes up into heaven. Button, we hardly knew ye. Now, I would love to stand up here and demo animations all morning. They are not going to let me do that. Other people need to do presentations. But I am so excited to start work on the animation chapter of my book. Now, let's, all right. Let's go back to the slides. All right. Now, I think that we're approaching a time when everything's going to be animated. Binary transitions are passé. Even Booleans will be animated. Booleans of the future won't be true and false. They'll be true, mostly true, pretty much true, maybe not, etc. So things like toggles and radio button controls, I think will need to be handled with transitions rather than just switching back and forth between things. So what on earth am I talking about? So you know that Xamarin.Forms supports XAML, right? That's pretty cool. But in connection with XAML, Xamarin.Forms also has a lot of infrastructure for the model view model architecture, otherwise known as MVVM. The view is the user interface. It's generally defined in XAML. Doesn't need to be. The model is the underlying data. The view model connects the underlying data with the view through data bindings. And Xamarin supports data bindings in XAML. Sometimes commands can be triggered in the view model. And for that purpose, Xamarin.Forms supports commanding, which lets you link user interface objects, such as buttons or toolbar items, with command methods in the view model. Although it's not quite as explicit as data binding and commanding, Xamarin.Forms also has some infrastructure support for behaviors, which involves attaching new functionality to existing user interface objects. Now, this infrastructure support are things called attached bindable properties. Jason Smith yesterday, during his presentation, said that Xamarin.Forms will soon support behaviors. So I've done a little behavior stuff on my own, but I'm going to just abandon that. I'm going to be using the Xamarin.Forms behaviors as soon as they're available. But if you'd like to experiment with some of this, attached bindable properties allow you to define properties that exist independently of the object on which the property is set. So you can define new properties on existing UI objects without any changes to these objects, without deriving new classes. Now, one of the sample programs I like to write when I'm coming to a new GUI API is a color selection program with scroll bars or sliders. Probably because that was one of the first programs I wrote for Windows that was published in a very ancient magazine called Microsoft Systems Journal. So far, I've written about 4 or 5 of these for Xamarin.Forms. And this is one that I'm calling MVVM color sliders. And let's run it first. As you can see, it has 3 sliders for selecting RGB colors, but it also has these little radio buttons, so you can switch between a hex representation and a float representation, and also to a hue, saturation, luminosity. And you'll notice that they just fade from one to the other. Now, one thing you should know that Xamarin.Forms has no radio buttons. And I did not create a radio button for this program. Instead, I have a radio button behavior that can be arbitrarily attached to regular UI objects, in this case, labels. Now, before I show you the XAML file for this page, the XAML file is already up, but I want to show you the code behind file. There it is, just a standard initialize component call. And you know what that means? That means that I get, if I can manage, I get an MVVM gold star. No code. Nobody else this week has gotten one of these. No code in the code behind file. This is not to say the program has no code. Au contraire. But all the UI stuff is in the XAML file. All the code, the actual C# code, is in the form of view models, value converters, UI-dependent behaviors. Let's see if we can look at the labels. Here are one of the labels that defines the radio buttons. And notice that there is some code, a behavior code, attached to this label that installs tap handlers and allows switching between them. And then the label itself has bindings from this radio behavior so that it can set its text color and font to indicate that it's the one that's been selected. Now, MVVM is commonly associated with stodgy line of business apps and stuff like that. However, at the opposite extreme are games. Now, in one sense, trying to code a game in Xamarin.Forms is quite fun because you really feel like you're pushing the outside of the envelope with what Xamarin.Forms can do. It's not quite what Tom Wolfe is talking about in the right stuff, but maybe a little. What is there in Xamarin.Forms that might be useful for games? So you've seen animations. You've seen how animations target transforms. There are also tap gestures in Xamarin.Forms that you've just seen with the radio buttons. But at the moment, Xamarin.Forms does not have a platform-independent vector graphics system. So if you need to do vector graphics, either you're doing some platform-specific coding, or in some cases, you can use the Xamarin.Forms box view. Now, the box view doesn't seem very sophisticated. It's just a box of solid color. However, you can make the box view whatever size you want, and you can make it skinny so it looks like a line, and you can rotate it so you can actually make box view, you can actually use box view to make lines. Let's look at a couple examples. You know what? I believe that I can do all these examples just from the simulator. OK. Here are several box views that have been sized so as to resemble lines, and then I rotate them in a spokes configuration just by animating the absolute layout in which they're arranged. And at some point, each of these spokes is also rotated around its center, which makes kind of a cool pattern. This is not too bad for a program that has no vector graphic, for a system that has no vector graphics support. Let's go to Home. And here's another example that I call the box view clock. Now, the tick marks are obviously box views because they're square. They actually look like box views. Many of them are rotated a bit just to give a nice little outline to the thing. The three hands are also box views with somewhat different widths and lengths to better resemble the traditional sizing of the hour, minute, and second hands. Now, as you know, when you're doing an analog clock app, you have a choice between a sweep second hand that goes continuously or a tick second hand that jumps from 1 second to the other. This is something in between. And all it was is like 2 lines of code applying one of the animation easing functions to the second hand, which I really I find it mesmerizing. I just love it, if I do say so myself. Let's go back to the slides here. That's my demo. I've been using a lot of graphics transforms in these examples. Here's a bit of a summary of what you have available. These transforms do not affect how the visual element is perceived in layout. So when you're animating something, you don't have a bunch of layout cycles triggered by the animations. You'll notice some rotation X and rotation Y properties. These are crazy 3D type transforms. The first rotates an object around the x-axis, so the top and bottom seem to come closer to or recede from the viewer. Rotation Y rotates around the y-axis, so the sides come closer or further away. Unfortunately, you don't have a lot of control over how these transforms are actually implemented. They have platform-specific implementations, so you're not going to be able to get them looking precisely the same in all 3 platforms. More demos. All right. Let's load in. Let's go home. And spinning image. OK. This uses the lower level animation facilities to apply somewhat out of sync animations to rotation, rotation X, rotation Y properties of an image, making it seem to be kind of a rotation around in 3D space. Now, something like this is kind of cool, but because there's no 3D matrix transform available, you can't really place these objects precisely in 3D space. And hence, you cannot do anything like 3D graphics. I mean, if you can't even do 2D vector graphics, you're not going to be able to do 3D vector graphics. However, if you want to do platform-independent 3D graphics in Xamarin.Forms, you can always go back to our old friend, the box view. And home, OK, there we go. And apply a bunch of math. That's all, box view plus math. And this is demonstrated in a program called Quasi 3D. That's kind of a pun. All right. And let's take a look at this. There's a rotating cube. 3D graphics is often like a magic show. You're really not seeing as much as you think you're seeing. There are no solids here. It's just box views. The box views in the background get a little different color and thickness, so it looks as if we're seeing them through a translucent solid. That's what I mean by the magic show. Let's go for the Casa. Ooh, nice. All right. Somebody on the Xamarin.Forms teams accused me of abusing the box view when I was doing stuff like this. There's our old friend, the dodecahedron. And then, of course, I got kind of cocky and tried to go for a sphere and brought the thing down to its knees. All right. Not too bad. What is that, like 2 frames a second? I don't know. Well, whereupon, this is Xamarin.Forms basically saying to me, hey, I may be cool, but there are limits to my coolness. Let's see, what else do I have in form of slides here? OK. You can do animation, like I was talking about the animation system, which at its heart uses a platform-specific timer that you can use directly. I've used that for a couple of these demos. You also have a couple of .NET tools to do timing stuff. You can use task delay with a way to introduce timing into your app without blocking the UI thread. You can use a stopwatch clock for calculating elapsed time. Aside from these weird demos, I've done 2, let's say, legitimate games for Xamarin.Forms. The first is a Xamarin.Forms version of the famous 1415 puzzle, which was one of the first games for the Mac. And then it was the only demo program for Windows that was written in Microsoft Pascal, where it was called Muzzle for Microsoft. So the one I have is called Zuzzle with an X. It's among the online Xamarin.Forms samples. It's been up on the Xamarin website since Xamarin.Forms was introduced. The second game that I've been working on recently is a totally original game I've invented called a Bug Sweeper. Let's go home, and I hope I have this on here. I was originally going to show you Bug Sweeper on the big screen on my Nexus 5, but we had technical issues. So let's try to run it here. OK. Now, this Bug Sweeper is a grid, and there are 10 hidden bugs. And the object is to flag a bug before you actually run it. So you can double-click, and then the numbers tell you that how many bugs are in the adjoining squares. So, and then when you flag a bug with Xamarin tools, of course. So let's see. All right. OK. There's one. All right. Am I going to be able to do this? All right. OK. Unfortunately, I'm still working a little on this program, and the graphics for the finishing up the game on the Mac, yeah, there's one. OK, getting close, getting close. That's good. 2 there. OK. And congratulations. And you can't really see that, but I'm going to have to work on that button. So this program and the clock program, I'm trying to get online in the Xamarin.Forms samples on the Xamarin website sometime Monday. The code's basically done. I need to do screenshots and stuff like that. But it'll be up there, and you can play around with it. But you know what's really, really cool about this program? It's platform-independent UI code. It runs on the iPhone, Android, Windows Phone, and it's all written in C# and XAML. And that is what's totally cool. Thank you very much. And it looks like we have 4 minutes for questions. There are microphones. Somebody's either leaving or leaving. Uh-oh. I don't have to answer questions. I don't know. I'm going to remove this now. This is, oops, ripped it. All right. Oh, well.
Now, since no one else has a question.
Yes. Hi.
Have you played around at all with this, the style features in the new XAML?
No, because what you do not do is load up a preview edition of an operating system or an API right before you're ready to do demos. And that is another thing for Monday morning. I really want to see what cool stuff that Jason and the guys have put into Xamarin.Forms for version 1.3. Yeah, there's a 1.3 preview. I think it's downloadable from the forums, and it's I'm psyched. I'm psyched because styles. As soon as you start working with the XAML, you say, I really wish we had styles, and of course, we're getting styles. Of course. Hi.
Hi. Probably been asked several times, but any plans on vector graphics for XAML.Forms?
I am in the docs team. You'd have to ask one of the developers. I ask the developers all the time that question. And the answer is, it seems like a reasonable thing to do. If you look at Xamarin.Forms and it's missing something, and you say, it's a really, really good idea to have this feature in there, very likely the Xamarin.Forms developers have also come to that same conclusion. So I think vector graphics is a no-brainer. It's not that easy. If you think about the underlying Windows platform, for example, Windows platform is all retained mode. The Windows Phone platform is all retained mode graphics. So do you jump immediately to a retained mode graphics system, or do you try to implement a direct mode graphics system on top of the Windows Phone retained mode graphics system? Or do you switch the Windows Phone API to WinRT and hence tap into DirectX on the Windows Phone? Gosh, that's the way I would do it. But I'm not in the development team for that. So we'll see. We'll see. But yeah, that's a very reasonable thing to have in there, vector graphics. Is there another question?
Yes, I had it while I was walking in. With custom renders and animation, is there a way to link through custom renders and custom animation, and what a custom render would actually do at various blend points in the animation?
Yeah, I think that you could, if you wanted to incorporate animation into your custom renderer, you could use the underlying animation system of the platform. if you had a control that you wanted animated in a particular way on all three platforms, that's probably the way I would do it. You implement both the visuals and the animation on the platform. Or you could have your custom renderer just do the visuals and use the Xamarin.Forms animation on top of that. That'll work too.
Say, for example, there was a fade that a custom renderer needed to do separately, differently. Would you be able to link into each keyframe of that fade and actually render what a fade would look like for that custom render?
Yeah, you should be able to do that. Yeah, if you make that a part of the renderer itself. Yeah, just a property or something, an additional property that of the control that's shadowed in the renderer. Yeah. Okay, we are at 0. We have to clear out for Jesse Liberty, or no, stay here for Jesse Liberty. Thank you.